Hi everyone. Right, today we are doing voltage, current, and resistance calculations. We went through current, voltage, and resistance individually in the previous 3 lessons, so now we're going to do some calculations. With resistance, in the last lesson, we calculated the total resistance of the circuit, and we did that by turning this into one resistor. These two combined to one resistor, which we measured out to be 2.4 ohms, we calculated. And so we got the total resistance of the circuit as 2 plus 2.4 plus 7, giving us 11.4 ohms. Okay. Now, that would not be enough to calculate the voltage or the current. We need one or the other. So what I want to do is to tell you that this voltage here of each cell is equal to 4 volts. So then you know if the voltage of each cell is 4 volts and you've got 3 cells, you know the voltage in the circuit is equal to 12 volts. Now, because we've got the total current and we have the voltage, we can, sorry, not the total current, because we have the total resistance and the voltage, we can work out the total current. So we know that the current I, from our triangle here, VRI triangle, we know that the current is equal to V over I. Sorry, V over R, which is equal to 12 over, the resistance was 11.4. And we can calculate that quickly. 12 over 11.4. 1,05 amps. Now, once we have this 1,05 amps, we are able to work out the voltages of A1 and A2, and they will both be the same, 1,05 amps and 1,05 amps, because they have not been split up. Now, the voltage, the current over the 6 ohm resistor would be slightly different. But we would need to work out the individual voltages first. So let's work out the voltage of V4 first. So we'll get V4. So this was the total current. V4 equals the current. So V equals R times I. So it's 7 times 1,05. And that gives us 7,35 volts. If we were to work out the voltage of V2 and V3, they are the same. So we wouldn't say V2 equals 6 times 1.05. That would be wrong. We have to treat the 6 ohm resistor and the 4 ohm resistor as the 2.4 ohm single resistor. So V2 is equal to 2.4 multiplied by 1.05. And that's equal to 2,52 volts. Okay, and I don't need to work out V3 because V3 is going to be the same. Okay. Now, if I was to put a voltmeter across the 2 ohm resistor, what I could do is I could say 12 minus 7.35 minus 2.4 2.52 because the voltage is being used up in the circuit. Remember how voltage works from that voltage video? It gets used up in the circuit. So if I was to do another voltage across here, across the 2 ohm resistor, it would be 12 minus 2.35 minus 2.52, which is 1,13. Let's just try that quickly and have a look. 12 R equals V over I. So voltage is to be 2 times 2,1. Now that I have the voltage, right, so now that I have the voltage across V2 and V3, I can work out the current across each of those, the 6 ohm resistor. So I across the 6 ohm resistor, so if I was to put an ammeter here, say, it would be V over R, which would be 2,52 over R, which is 6, and that would equal 2.52 divided by 6 equals 0,42. And I across the 4 ohm resistor would be 2.52 divided by 4. And that equals 0,63. Now, if I add those up, 0,63 plus 0,42, they combine to be 1,05, which makes sense because got to put in your units, because my total current is 1,05, so it's split. 0,42 went up here to the 6 ohm resistor, and 0,63 went down here. More current flowed through the smaller resistor. Okay, so that's our voltage, current, and voltage and current calculations using the resistance that we calculated in the last lesson. So that's it for now, and in the next lesson we will be doing power calculations and possibly charge as well.